Okay, let's take a look at some examples of solving absolute value equations and inequalities. This first example is an equality because it has an equal sign. I have the absolute value of x divided by 4 minus 6 is equal to negative 2. Okay, by now you should at least have these steps or something similar written in your notes, but let's go through them. We're going to isolate the absolute value expression. By that I mean on the one side of the equation I need the absolute value expression and nothing else. And so I'm going to add 6 to both sides. Then I am going to strip the absolute value bars off and rewrite it as the positive case and the negative case. Finally, I solve for the variable. In this case, I multiply both sides by 4, and my answer is x is equal to 16 or x is equal to negative 16. Now, if I wanted to graph this, I'd simply have two closed points on 16 and negative 16 on a number line. Pause now and copy down this example. Our next example, absolute value of 6x minus 8 is equal to 22. Well, I follow the same steps. I'm going to isolate the absolute value expression by adding 8 to both sides. That gives me the absolute value of 6x is equal to 30. I'm going to strip off the absolute value bars and rewrite it with my two case. The case where it's equal to positive 30 and the case where it's equal to negative 30. And finally, I'm going to solve for x. I'm going to do that by dividing both sides by 6. My answer is x equal 5 or x is equal to negative 5. If I were going to graph this on a number line, I would have one closed point on positive 5 and one closed point on negative 5. It's as simple as that. Pause now and make sure that you have this example in your notes. Here is an example of that number line I was talking about. Now, you can solve absolute value inequalities using the same methods that you use to solve equations. First, you have to isolate the absolute value expression. You have to get that on one side all by itself. Then you rewrite using the positive case, considering the positive case and the negative case. And again, you're going to need to strip the bars off the absolute value function. And last, you're going to solve for your variable, or in the case of these notes, x. Pause now and make sure that you have all three of these steps in your notes. All right, let's look at our first example. It is the absolute value of negative 4q plus 2 is greater than or equal to 10. All right, so I only have an absolute value on one side of this inequality, so I don't have to isolate it or do anything to get it by itself. So I'm going to start with stripping the absolute value bars off and then rewriting it with my two cases. The case where it's greater than or equal to positive 10, or the negative case, the case where it is less than or equal to negative 10. Now, let's talk a little bit about why that inequality had to flip. When we write the negative case, essentially what we're doing is multiplying one side of the equation by negative 1. Anytime you multiply an inequality, an expression and an inequality by a negative number or divide it by a negative number, you must flip the inequality. And so we have done that here. Please make special note of that in your notes, that when you consider the negative case, you have to flip the inequality. Okay, now that we're past that, we're going to go ahead and solve for the variable q by subtracting 2 from both sides and then dividing by negative 4 in both cases. Now, again, when I divide by a negative number, I must flip the inequality. So we see that for the first case, case 1, Q is less than or equal to negative 2. And in the case 2, we had to flip that sign, and now Q is greater than or equal to 3. And finally, here's how you would graph the solution to this inequality. You would start with a closed point at 3, and then have an arrow going up to signify greater than. For example, 4 is definitely greater than 3, and it is included in this solution. Then we'd have another closed point at negative 2, pointing down. For example, negative 5 is definitely less than negative 2, and it is included in this solution. Pause now and make sure that you take notes on this example, especially the idea that when you divide or multiply by a negative number and you're dealing with an inequality, you must flip the inequality. Okay, let's take a look at our next example of an inequality. This one, the absolute value of 3x and then plus 36 is greater than 12. Now in this one we do need to isolate the absolute value expression, and so we're going to do that by subtracting 36 from both sides. Now we can talk in class if you remind me about the term disjunction, but for now just note it and let's go on. So now we're going to do our second step. We're going to write it as our two cases. So we strip the absolute value bars off, and we have to make it greater than negative 24. And then for the second case, we need to flip the sign. You always flip the sign for the second case. And so now we're considering 3x is less than negative 24. That would give me a positive 24. All right, then I'm going to solve. In this case, I'm going to divide both sides by positive 3, so I don't have to flip the inequalities again. X, it turns out, is greater than negative 8 or less than 8. That ends up being all real numbers. And the graph of that solution would look like that. Pause now and copy down this example. Okay, let's take a look at this example. Now we have the absolute value of 2x plus 7, all divided by just regular 3, is less than or equal to 1. Okay, so we do have to isolate the absolute value expression, and we will do that by multiplying both sides by 3. No need to flip the sign because we're multiplying by a positive number. And then we will consider the two cases. The positive case, 2x plus 7 is less than or equal to 3. And the negative case, 2x plus 7 is greater than or equal to negative 3. Now we had to flip the inequality here because we are talking about negative 3. All right, so I'm going to solve from here for x. I, in both cases, subtract 7 from both sides, and in both cases, divide both sides by 2. Again, I'm dividing by a positive number, so I do not need to flip the sign, flip the inequalities again. My solution is x is greater than or less than or equal to negative 2, but x is also greater than or equal to negative 5. It includes negative 5, and negative 2, and all of the numbers in between. This is what that graph looks like. Let's take a look at a couple of word problems. Okay, we have 20 cubic feet of marble can weigh 3,400 plus or minus 100, and that's 3,400 tons plus or minus 100. All right, so we are going to write and solve an absolute value inequality for the possible weights of the marble. So we set up our equation to look like this. We have 20 cubic feet times so many pieces of marble, we don't know how many we have, minus 3,400, that's how much it can weigh, is less than or equal to 100. Okay, so we're going to write our two cases. Now, I have a typo here. The first case is 20x minus 3,400 is less than 100. That 10 should read 100. Or 20x minus 3,400 is greater than or equal to negative 100. Now, our 20 cubic feet of marble can weigh 100 pounds more. That is case 1. Or 100 pounds less. That is case 2. Now I'm going to add 3,400 to both sides in both cases, and in both cases divide by 20 and get my answers that x can be less than or equal to 175, or x can be greater than or equal to 165. All right, so x is less than 175 and greater than or equal to 165. Pause now and copy down this example. Now please note, we gave you this example for you to understand how absolute values might be used in a word problem, but there is no problem like this on the test. Now, here's another and our last word problem for this session. You are at a miniature golf course, I wish I was right now, and you're trying to make a hole-in-one. Now, if I placed a coordinate plane over this picture of the golf green, I would see that the golf ball is currently at 2.5 and 2, and that the hole is at 9.5 and 2. Now, I plan to make a bank shot at 6.8 on the wall. And I'm wondering if I will make that shot. I need to write an equation for the path of the ball and predict whether or not I'm going to make this shot. So let's take a look. I realize from the description of the problem and this picture that the vertex is at x equals 6, y is equal to 8. So I go ahead and start writing my equation in the vertex form based on that. And I end up with y is equal to a, I still don't know a, so I'm going to leave it as a, times the absolute value of x minus 6 plus 8. And then I'm going to use the other point, the point where the ball is located, to solve for a. So I substitute in 2.5 for x and 2 for y and do all this solving and end up with the answer that a is equal to negative 1.714, and I round it to the nearest thousandths at this point because that's what we want you to do by default unless we give you other instructions to round in some other way. All right, but I have my equation, but I still don't know whether or not I'm going to make the shot. I look at my graph and my picture, and based on what I know about absolute value functions, I realize that the point 9.5 and 2 is symmetrical with the point 2.5, 2. So yes, I will make the shot. Go, Mrs. Clark. Now, pause now and copy down this example. There are problems like this on the test where you need to identify the vertex, write the equation, and then solve for A in order to answer the question. Make sure that you note any questions that you have and bring them to class, and I will do my level best to answer all your questions.